So hi, I'm Harsh. I'm from LocalStack, and I guess I must be the guy who was pestering you over emails and everything. So first of all, thanks for just let me start my stopwatch so that I just don't lose track of the time. Yes, awesome. So yeah, I'm Harsh. I have been working with LocalStack since 2021. I was one of the first employees to start working from India. Maybe the second, I'm not sure. That is totally dependent on the technical details. But here I'm going to talk about developing and testing data pipelines on your local machine with LocalStack. So with that said, I guess we can start with a very basic audience session. So what I would really like to ask from all of you is to take out your smartphone or your laptop, go to slido.com or maybe scan the QR code and just join this session. I have really three basic questions that I need to ask you so that I can understand what kind of an audience I'm dealing with. And based on that, I can further alter my talk, maybe in the midst of everything. So in this case, not sure. Just yeah, just give me a second, please. I guess I just closed my Slido session. Hmm. Yeah. So this one should show the whole QR code and the number over here. Has everyone joined? So if everyone has joined, maybe I can start this up really quick. Um, yes, and the very first question is like, what public cloud provider do you use? AWS, GCP, Azure, any other, Alibaba, Vulture, something else? Okay, it seems like the overwhelming majority is in favor of AWS. Some are in Azure, some are in GCP. Who else is using anything apart from that? Anyone? What are you using? Hmm? Oracle. Okay, wow, that's cool. Anyone else who is using some other cloud provider? Yeah, I guess we had the last meetup at Dukan, and like they kind of migrated from cloud to using Vulture. So I guess that sounds cool. Maybe the second question. Have you ever used Snowflake? So I'm gonna do like a product sneak peek. I guess this is the first time we are publicly demonstrating this, and this question is super relevant. I guess I won't have to give a lot of spoilers. Okay, I know about Snowflake, but never used. How many of you work professionally with Snowflake? I guess, yeah, he works. Anyone else? Okay, they are using Snowflake professionally. That sounds cool. And maybe the final question that I wanted to ask is, have you heard about or used LocalStack before? I know the answer to this. It would be an overwhelming no, but there are some yes. Who has used LocalStack before? Anyone? Yeah. Awesome. So I guess there is a pretty good number, and this is perfectly the audience that kind of aligns with what I have prepared. So maybe let's not jump into any further questions and let's check out the agenda. So yes, I really want to talk a bit about why develop and test locally. What's the basic motivation in that, and why shouldn't you test everything directly on the cloud? I guess that's the best way of doing it. Maybe not the cheapest way, maybe not the most efficient way, but still the best way. But why should you just take a trade-off and start developing on your local machine itself? What is local stack? Like what the heck this whole tech is? Then I want to demonstrate the whole real-time data pipelines, because this kind of integrates into the sneak peek that I want to do, which is a completely new Snowflake emulator that I have been personally working on for past few weeks or so. And finally, we will just do a wrap up and a simple Q&A. So yes, let's talk about why develop and test locally. Anyone who has been testing on the cloud itself, like whatever they work on or whatever they build, they just directly go to the cloud, upload their code, and just test everything over there. Anyone who has been doing that? Come on, folks. Some of you mentioned that you're using AWS. Okay, Param is doing that. Anyone else? Yeah, Chinmay is doing that. So yeah, obviously, I guess if you attended the last Cloud Dev Exchange, Nancy presented this whole nice story about, I guess, Pooja. Over here, I made it about Alice. So if you're building a cloud application, there are a lot of interconnected dependencies that you have no control over, like things like databases or message queues or virtual machines or object storage. Obviously, some folks, like Chinmay already told about it, it's about building cloud agnostic solutions. But in case of normal people like us, it's completely like we have to depend on a public cloud for having all of these dependencies. And the problem is that these dependencies are not open source, which means that for testing them, we have to directly go to a managed cloud provider and basically spend some money or spend some of our time in kind of doing that. Now, this whole development and testing loop, this whole developer experience, it's very, very slow. It's very, very tedious. Like just imagine if you're testing your something like simple as Lambda function. Every time you update your Lambda function, you have to package up the whole zip, push it to the AWS, invoke it, get a successful message, and then only you can proceed ahead. This is a very bad developer experience. This is something that absolutely sucks about public cloud providers, especially about AWS, I would say. And on top of this, if something goes wrong, like let us say if you're using like feature branches or something like that, and you're pushing code over there, it directly deploys on the public cloud and you're just testing things over there. If something goes red, you simply have no idea, which means that you have to tear down those resources, maybe enable some verbose logging, then go into that and figure out like what's exactly going wrong. And on top of this, if you're a developer manager, this is going to be a headache for you because cost will start spiking up. A lot of the employees that you're dealing with, they would be spending most of their time in just deploying, testing, and like figuring out like what's exactly going wrong. So at the end, there are three main challenges with today's cloud development: slow feedback loops, remote debuggability, and managing your developer infrastructure. And these three are one of the core problems why we started LocalStack. So this basically means that over the cloud, developers are facing a lot of challenges. The very first one is efficiency. Things are not as efficient as before. Many of you are just spending minutes and hours of your entire day in just figuring out the cloud. Uh, the inner dev loop, which basically means that if I'm working on my IDE, I'm just making a code change, I'm pushing that to the cloud, and I'm just testing things out. So this basically constitutes the inner dev loop that is extremely slow right now. The second aspect is debuggability. Like you cannot attach a debugger to like the public cloud or basically test out things that you do in the normal software development process. And on top of this, there are resource conflicts. Like for example, how many of you use staging environments? I guess most of you must be using it. How many of you just overstep on each other's toe? Like someone else is using staging environment, now you cannot use it, things like that. Anyone? Yes. So these resource conflicts are quite common if you're using the public cloud just for testing things over there. So there are multiple approaches of fixing this problem. So I'm not going to say like LocalStack is the only like company out there that's fixing it. There are many other projects as well. I guess the very first one is AWS itself. There is this whole remote execution model. And this basically means that whatever code you build and deploy, just do it on the public cloud, figure things out over there, and then you can proceed from there itself. I guess there are some pretty great products like Cloud9, which is like a cloud-based IDE that AWS provides. And it has a certainly good developer experience. I'm recently testing out Code Catalyst, which is another product by AWS, and it is certainly becoming more matured. Cloud proxies is another way. This is where platforms like SST and Lightrun is pretty famous. It basically means that your cloud, like your applications are still being tested on the cloud, but there is a proxy tunneling that will give you an experience that it's happening all on your local machine. Like SST's live Lambda execution was a mind-blowing feature for us. Like we have a similar thing, but it was so fast and everything had a pretty high fidelity and high parity. That was something that was mind-blowing for them as well. And obviously, you have got local emulation, which is where LocalStack and maybe some other projects like Architect or Moto comes in. And this basically means that all of your application and your tests are running locally. You have faster development cycles, which means that you do not have to depend on the public cloud at all. So this brings us to like, mhm, 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 yeah, 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 yeah. So yeah, what is local stack? Yeah, thanks for the great point. So yes, it's a fully functional local cloud stack. Just to give a bit of history, it started at Atlassian back in 2016, and it was basically bootstrapped over there itself. And this basically gave us the boost of like building this out as a more proper open source project. So if I just give like a very background, you can actually go to the GitHub and you can just check out the whole project over there. It has got like almost 51,000 plus GitHub stars, which makes it like one of the most popular projects on GitHub for the time being. Yes, so it enables the highly efficient dev and test loop. It is shipped as a Docker image, and this basically means that you don't have to do a lot of manual installation or setup or anything like that. Just say like Docker pull local stack slash local stack, Docker run local stack slash local stack, and everything is pretty much set up. It has support for 100 plus AWS APIs. I guess the number has increased from 70 the last year to almost 100 plus right now. For compute, databases, messaging, sophisticated APIs, and things like that. And on top of this, there are some more collaboration features, integrations that I guess would be beyond the scope for this particular session. So just to give like all of those technical geeks, like how architecture in LocalStack is basically being made. So LocalStack runs inside the Docker container. So for LocalStack, Docker is kind of a mini cloud operating system. And over there, what we do is like we basically build these service emulators. So like we have services like Lambda, S3, DynamoDB. In some of the cases, we basically use open source projects like K3s or DynamoDB local to kind of integrate that. In some other cases, we just rewrite the whole service from scratch. Like S3 and SQS are the best examples for that. Then we have something that's called as the AWS protocol. So we have a framework that's called as the Amazon Server Framework. And what it does is like it basically builds the API specification for our AWS cloud, and it basically integrates the service emulators with the protocol over there. And using this protocol, you can pretty much integrate this with any of the integrations like Terraform or Pulumi or CDK or whatsoever. And if you look at it from a 10,000 feet view, this is how it looks like. LocalStack is not a replacement for AWS or any other public cloud. It basically means that it's a drop-in replacement on your local machine and on your CI. Because now with this, you do not have to develop and test anything on the real cloud. You can just do it on the local stack. You can get a quick validation. And this would certainly be something that you would continuously love because everything is happening on your local machine. You can create, you can tear down the resources, you can analyze them, and this is going to certainly give you like a much faster experience and a better way of doing things. So just want to give you like a very short, quick start about how it is like to basically build on LocalStack. Yes, yeah, we have a complete database of all the IAM roles and policies. So yeah. So in this case, I'm going to start my LocalStack container. So in this case, I'm just using the LocalStack CLI, but you can swap this with a Docker configuration or a Docker compose, or even install it using a Helm chart. So my LocalStack container is ready. If you have used LocalStack maybe 3 or 4 years back, and you see like, okay, LocalStack is so much faster now, it's because every service is being lazily loaded. So in this case, I can go ahead and maybe I can just run like a very basic command, maybe something like, yeah. So over here, what I'm doing is like I'm creating an S3 bucket. How many of you know S3? I guess most of you. If you don't know S3, then it's just a basic object storage solution that AWS provides, one of the first service that AWS built. And I'm just creating a hello world file in my temporary directory, just copying that file into my S3 bucket. And now this file is available pretty much on my local machine. Now, this isn't a bucket that's created on the real cloud, on the real AWS. It's just running locally. And if I just show you a quick interface, you can actually go to the LocalStack dashboard. So this is like one of the web apps that's free for use, at least for these services. You can actually see that for our S3 service, we have the test bucket that we have created previously. Now, if I shut down my container, what exactly happens? Can anyone say what happens if I shut down my container? Yeah, file is not visible simply because all of the resources that we have created is ephemeral in nature, which means that if we shut down the container, it's just goes, it vanishes because everything is being created inside the container or maybe in some external container. And once we shut it down, all of the resources are basically deleted. So no more spinning up an EC2 instance or S3 bucket or Lambda function and worrying about like, if I don't shut it down, I'll start incurring some AWS charges. We can do that. Yeah. So one demo that I want to showcase, maybe let me just grab a chair because it's a long and tiring day for me personally. So I want to show a demo on how you can test some real-time data pipelines with LocalStack. So how many of you can see my screen and maybe my VS Code terminal? Is everything visible? Mm-hmm. Okay, font size, yeah. Is it better now? Okay, maybe let me just, mhm. Okay, yeah, I'll do that. But actually I need it for the time being, so Yeah. So yeah, let me just go back to my demo and just tell you like what exactly it is about. So I did not bring out a very simple demo application or anything like that because that's what common with meetups. I actually extracted like one of the critical pieces of our own infrastructure just to show you like how we actually build and test things on our own side, how we basically dog food our own product. So in this case, what we do is like in case of LocalStack, we basically orchestrate and we basically build our own application set using a lot of serverless components. And one of our components is pretty much analytics. So you can see over here, maybe let me just start my laser pointer. So I have an AWS Lambda function that basically emits some analytics event. And what I need to do is like, I need to analyze this analytics event, kind of pick out the necessary details for me and put this in my Tinybird data warehouse. Has anyone heard about Tinybird before? Anyone? Yeah, Chinmay has heard about it. For anyone who doesn't know about Tinybird, it's basically a data warehouse that's built on ClickHouse clusters. Let me tell you, this is the best data product that we have personally used. So what we need is like we need to extract the analytics and we need to push that to our Tinybird warehouse. But we cannot just dump all of the analytics or all of the event that we are getting right into the warehouse itself. We need to do some processing. We need to do some analyzing. So in this case, we are using CloudWatch over here, which has got something that's called as subscription filters. So these subscription filters will basically extract these events, and this will pass it down to the Amazon Kinesis. And in case of this Amazon Kinesis, like it will pick up these events and it will send it to another Lambda function, basically as batches. And this Lambda function will put everything into this particular Tinybird data warehouse. So all of this analytics event is generally like JSON payload. And we basically need to build out an application that can basically test and integrate this. So in this case, what's happening is I can maybe show you my code right now. So in this case, I have two Lambda functions. The first Lambda function is called as test logger. Okay, maybe let's not, yeah, this one. So we have something that's called as a test logger, and it does a very simple thing. It basically mimics a Lambda function that just prints like some particular like JSON right over here. So it contains the event class, it contains the event type, and the subscription filters are basically filtering for these particular payloads itself. Then we have got something called as the Kinesis Tinybird loader. So this is another Lambda function, and it basically allows us, like it's the second Lambda function that I showed over here, right, this one. And this Lambda function basically allows me to extract the analytics event from the Kinesis stream and basically load that event to Tinybird. Now, Tinybird is a closed source project. Again, the whole fundamental aspect about like open source versus closed source. So we cannot like really bring Tinybird down to our local machine. So what do we do in that case? We mocked Tinybird right over here. So in this case, what we have done is that if you actually go to our tests and you go to our integration, you will see like that we have basically mocked the Tinybird. So Tinybird accepts like HTTP APIs, SQL interfaces, and all of these things. So all we did is like we basically use this library called as HTTP server mock, and it basically accepts any sort of post request that mimics what a mocked Tinybird warehouse might look like. Again, not a very ideal solution, but something that we use personally. Um, so yes, that's it about like how this whole application is structured. We also have like a makefile target, but let me just quickly describe how we are going to deploy this. So in this case, we are going to deploy the whole infrastructure using CDK. How many of you have used CDK before? Okay, quite a few hands. So CDK, for the people who don't know, it's a very, very popular tool to define your infrastructure as code within AWS. AWS has got like many IIC services, like it has got CDK, serverless application model, uh, CloudFormation. But at the end of the day, all of these IIC frameworks, all they do is like they compile and they synthesize the whole thing into CloudFormation. And the CloudFormation is what you can see is like the real processor of deploying your infrastructure through some manual code configurations. So in the similar case as well, CDK programs are compiled into CloudFormation stacks and they are basically deployed on LocalStack itself. Now you might be asking like, how can I deploy my CDK stacks on LocalStack itself? So in this case, we have a project called as CDK Local. And CDK Local is basically a wrapper script on CDK itself. And what it does is like it allows you to deploy your CDK stack completely against LocalStack. So at the end of the day, it's very simple. It compiles your entire CDK into CloudFormation, and then it uploads the CloudFormation to an S3 bucket. And from there, LocalStack will deploy this like as an application. So yeah, that's what we are gonna use. And if I just show you my CDK stack itself, so this is where my CDK is located. By the way, this code is pretty much open source. It's on Hirsch Casper serverless streaming data pipeline. So you can just check it out after this session. So in this CDK pipeline, all that we have is two stacks. We have this local app that basically deploys my data pipeline stack, and it contains the Lambda function that I showed you just before that basically prints some JSON data over there. And over here, we have this data pipeline stack, which basically is a CDK class stack. And this has got all of the CloudWatch log groups that basically filters for this event class and event type. I guess like some of you might not be aware of this whole AWS jargon language, but I guess this whole walkthrough should be quite simple to you. And after that, we basically create our Lambda functions. We set up our Tinybird auth token. So in that case, we don't have to make a lot of changes to our setup. We can just set up some mock tokens over here, like mock auth token and mock URL, and we can be just over with that. So to simplify this whole process, I have a makefile. How many of you know about makefile targets? I guess quite a number of you. So in this case, I'm just using these makefile targets to basically build my code, install the dependencies, deploy the resources, and all of these things. So what we can do is like we can just go ahead maybe, and we can start the local stack container. I can maybe close the Explorer now. Thanks for the advice. And this is gonna start my container. It's pretty much ready. And I can go to my other terminal. I can just activate my virtual environment, and I can install my dependencies. So this is gonna set up all of the things for me, which I already did before. And once this is done, I can go ahead and I can see like make deploy local. So if I just show you the makefile target for this, what you can see is like it is actually using this whole CDK local itself. And this basically tells CDK like, do not deploy this on AWS, please deploy this on LocalStack itself. So this will start the deployment process. It's gonna take a few seconds. But the more interesting part is like how LocalStack deploys this. So maybe I can just open my container logs. And if I just increase the size of it, you can see like what LocalStack is doing is like it is passing in a lot of these CloudFormation API calls. It is starting like a local ECR Docker registry, and it is like executing a lot of different AWS APIs pretty much on your local machine itself. So this whole logging experience can give you a really nice insight about what's exactly happening with your application and what you can basically do to fix things if something is basically going wrong. So if I just go back, this is gonna take a few more seconds. On the real AWS, it takes about 2 or 3 minutes to deploy, but on LocalStack, it's mostly about like less than half a minute or so, if you exclude the whole bootstrap process. So I guess this is deployed. The whole time that it took was almost 19 seconds or so, and your entire application is pretty much ready on your local machine. Now you might be asking is like, how can I test this? So the very best way to test this is like just using this makefile target. And what it does is like it invokes this particular Lambda function. It passes this in the payload, which is hello world. And these are some like CLI binary format that I have set up just because of my own local machine. I just use a very old version of AWS CLI. So I can do this make invoke test logger local, and you can see the Lambda function has been successfully executed. But where do I see the data in the Tinybird warehouse? So in this case, what I'm going to do is that I'm going to start a request recorder, which is basically our Tinybird warehouse that is being mocked. And this starts my app. And you can see on the logs itself is that you can see a hello world message right over here. I hope it is visible to everyone altogether. I can also just go ahead and maybe like, let me just reduce that. And maybe just change it to hello Hirsch. And if I just re-execute my Lambda function, just invoke it once again. And if you go back to the test logger, like this whole request recorder, you can see like hello Hirsch is present right over here. So this gives you like a pretty nice dev and test experience. Everything is happening on your local machine. I can shut down my internet and this whole app will still work out. Now, what about running integration tests? How many of you like run integration tests on your app deployments? I guess a few of you. So you can also write your integration tests so that you can be really sure that everything is running pretty much good. And in this case, we have got this whole simple E2E test that I have wrote. It was really, really flaky. I just got to make it work somehow. But if I just go back, yeah, maybe just close this whole thing down and just mention like to kill this port because this is gonna bother me. I can just say like test integration, and this is gonna start my whole integration test once again. And this is much better to like actually execute on things like CI pipelines and all of these particular parts because it can give like a really quick validation that hey, everything is running pretty much successfully. So this was it about the demo. This is how LocalStack basically helps you the whole dev and test experience. Everything that you saw over here is pretty much in the open source project. So you don't need to like use LocalStack Pro or any of the paid tiers. You can just go with the free and open source version, and you can pretty much achieve a great degree of parity for your AWS app deployments. So yes, this was a demo. So why exactly do you want to use LocalStack? I guess the very first reason is that you want to avoid these whole deploy times and tear down time on AWS. Everything is running locally, so it gives you like a pretty great degree of freedom to just tinker around, play around with things, and get a nice feel about what's exactly happening. The second one is that there is no interference, so like not stepping on each other's toes in a staging environment or anything of that sort. And finally, you can query from all services directly. Like sometimes you might be deploying an S3 bucket or a DynamoDB table, and there might be certain restrictions about querying that data or something like that. Nothing like this happens. Everything is on your local machine. Just go mad or go crazy and just do whatever you want to do over there. So since we have just 5 minutes left, okay, maybe I'm just going a bit. Yeah, I guess this was it. So yes, I just wanted to give a sneak peek of something that my team has been working on for the past few months, and that LocalStack is not just limited to AWS right now. We have been taking a crack on some of the new services, and one of the services that we are taking a crack on is Snowflake. So for anyone who is not aware about what Snowflake exactly is, I guess the best place is the Snowflake website itself. It's a complete data cloud solution that allows you to create databases, warehouses, tables, multiple other things, do a lot of crazy stuff with your data itself, and achieve quite a great degree of like flexibility with how you want to build out your own applications. So Snowflake was something that was being asked by like a lot of people on public forums and things like that. So we took the feedback and we started building out the whole Snowflake emulator like 2 or 3 months back itself. We gave like a really nice sneak peek at the AWS reInvent, but it was not ready there yet. And this is the first time we actually made sure that the general public knows about it. So what it does is like it implements and it emulates the actual Snowflake API process. So whatever Snowflake toolings that you're using, Snowpark, SnowSQL, or something like that, it integrates with that. And for any one of you who is interested to know how we are doing this, we are basically building on Postgres itself. The Postgres SQL is the underlying engine that we are using. And we use a library that's called as the SQL Glot. And this basically transpiles the the Snowflake queries into actual Postgres queries and give you like a really nice emulation about how it's exactly working. And yes, you can take this emulator, it's shipped as a Docker image. You can take this and you can easily extend it from your local development to the CI environment and do a lot of things with that. Just to give you a heads up, there is a nice documentation that I worked on, and it contains every bit of information that we have implemented. If you check the functions coverage, it is less than 10% as of now, or maybe a bit better. But Snowflake function coverage is pretty huge, and we have just took the humongous job of like actually implementing some of them right now, which I guess still needs to be improved. But we would definitely love to have your feedback and love to have you try this out and give us like some nice insights on what's exactly possible. Coming onto the feature set, I guess it's pretty good. You can do some basic operations on warehouses, databases, schemas. You can store your files in stages. You can use Snowpark libraries. You can use Snowpipe streaming with some Kafka connectors. So these are all of the technical jargon terms for anyone like who is much aware about Snowflake itself. But since I just have maybe a minute left, I can just show you how it exactly works. So just one last demo for the day. So what I can do is I can stop my local stack container and I can just start it once again once this gets over with. Yeah. So I can specify this whole image name called as local stack slash snowflake. So just like how you pull the local stack Docker image, you can just pull the snowflake image, which is at local stack snowflake, and just put this config variable, and this is gonna start the snowflake emulator. Yes, so this is starting it up as of now. This activates my license. And once this is done, I can use something that's called as a SnowSQL, like that's a SQL client that Snowflake provides. And over here, you can see like I have mentioned like my account as a test, my username as test, my host as snowflake.localhost.localstack.cloud. That's the DNS name that we have specified. The port is 4566. And once you hit enter, you will basically get to see like Snowflake, like this whole SnowSQL connecting to your local stack Snowflake instance. I'm not sure what's going wrong, or maybe it's installing a few things. Yes, SnowSQL is up. So in this case, like I have a few basic queries that I can just show you really quick. But in this case, you can just go ahead, create things like a demo database. You can go ahead, select the current database and the current schema. You can create tables right over here. And you can even like create your data warehouses pretty much right on your local machine. And if you actually go back to the LocalStack logs, I guess the log experience is not that great, but definitely something that we want to improve on. And this will certainly come to a stage where you can easily build, test, and debug your Snowflake apps running on your local machine. Yes, this was about it. I guess I finished it on time, 5 minutes before my stopwatch. So I'm open to questions now. Thank you.